Alright, I'm doing a little torque converter solenoid swap this morning on David's T-Type. It sticks after a rather long test drive, so I'm going to make a little video on the basics of the torque converter clutch operation. First of all, probably 80 to 90% of the cars that I work on are street cars, and if the customer asks me what I recommend, I usually recommend the lockup. However, here's the chart. This is the factory chart. Notice it says Turbo G series. Okay, so we have the voltage, which comes from the fuse, the ignition fuse. Gets interrupted by the brake switch when you step on the brakes, and it comes down to pin A on the ALDL, which goes then to the solenoid. You have the ground, which is controlled by the computer, by the driver, and that runs all the way down to the transmission as well, which is also on pin F of the ALDL connector. It looks like ALCL. So yes, you can force it to lock up if you jump the pins. And then you have the pressure switches. The pressure switches are normally closed, which means they're normally grounded, and they're inputs to the computer. So when the computer sees it open, when it sees third gear open and it says, hey, I'm in third gear. We all know a stock chip will lock up in third gear. I think some turbo tweak chips lock up based on mile per hour, maybe, not the third gear signal. Eric might correct me on that. And then other chips, like Bob's chips, they only lock up in fourth gear, so they won't lock up until the switch closes. So if these switches are gone, if they're not working, it can cause problems. You can also just get your chip burner to totally ignore the switches and do it by mile per hour. A lot of aftermarket ECUs do it by mile per hour, like ECU GN, stuff like that. But usually all that goes wrong is a couple things. The driver and the computer will burn out. I've had that happen. You blow the fuse by doing something dumb. The solenoid itself sticks, which is what's the case in this car. And also not pictured on there, well, there it is, a brake switch. The brake switch can come out of adjustment, or it cannot work, you know, wear and tear on things. So there's your electrical schematic. Okay, here's the tree. You're gonna have to, I don't know if y'all can screenshot that, but that's the tree. This car here, basically, it'll run 30-40 miles and then it will lock. And I can tell when it downshifts that it's locked, it won't unlock. Let it cool off, it unlocks, and I drive it. So this here is certainly a factory solenoid, probably original in the car. This is an aftermarket one. This is a standard motor brand. If you notice, the solenoid is a little bit longer, so they give you these studs, which will screw up in there. Well, you get it right, we'll flip it around, they'll screw up in there. And I've already stripped the wires. You can use their cute little screw-in connectors, or you can go to butt connectors with heat shrink. But that's pretty much it. It's pretty basic. It's a basic system. It, you know, it's designed for a little bit more fuel mileage back in the emissions era when these cars were built. You know, I don't really disable it very often. On race cars, you do disable it because you can get a better converter, supposedly, if you get rid of lockup. But for the guys that drive on the street, a lot of them, and guys with low mileage cars, they run into the solenoid sticking. So if you get a sticking solenoid, this is for you. This is how to fix it. I've already verified that this wire is always hot with the ignition on, and this wire would be grounded. Excuse me, that one would be grounded by the computer when the computer sees fit to lock it up. So there's an overview on TCC lockup and when they stick and how to fix them.